In this video, I will cover everything you need to know about the Lakehouse for the DP-700 exam. Stay tuned! Welcome to the video. My name is Alex and on this channel I cover Microsoft Fabric and Azure related topics. And in this video we will continue our DP-700 exam prep series, and link to the entire playlist can be found in the description. This is the episode 12 in this DP-700 exam prep series, and in this episode we are going to cover one of the main data stores in Fabric, Lakehouse. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in the episode, so that you can test your knowledge. But now, let's get started. Let's first cover an overview of Lakehouse and then dive deeper into specific parts and concepts related to it. First, we have to have a Fabric environment to which we can then create a Lakehouse. The cool thing about the Lakehouse is that it can store files and tables. So basically in this data store we have two main sections. Good thing to rehearse here is that when we are storing data to Lakehouse, we are actually storing it to OneLake under the hood. And using Lakehouse is just one way of storing data to OneLake. That is the underlying data store in Microsoft Fabric. That is basically this unified data lake for entire organization. And there is only one OneLake per Fabric, like the name implies. Also, good thing to know is that OneLake is based on the same technology than Azure Data Lake Storage, and Microsoft has just repackaged it into Fabric to this software as a service or SaaS Azure Data Lake. So, like said, we can store files and tables to Lakehouse. This means that we can store data in very raw formats like CSV and JSON files, and thus Lakehouse is an excellent data store for ingesting and archiving data, since you can land the data there in any format you want. So, typically in Medallion architecture, Lakehouse is used as the bronze layer data store for this reason, and of course it can be used for silver and gold layers as well. And when I say that you can store data in any format you want, I really mean that. And you can store more untraditional data there for data engineering purposes like video and audio files, if you so desire. For tables, Lakehouse uses Delta Parquet as its default data format. Delta Parquet is this very powerful and optimized open source data format, and it is the same data format that is being used, for example, in Databricks. Delta Parquet is also default data format used in the entire OneLake. And when we cover more Fabric data stores and mirroring, we will run into Delta Parquet format over and over again. Also, later in this episode, we will talk about optimizing and maintaining those Delta tables, since that is a key thing to know in the DP-700 exam. One cool thing about the Lakehouse is that it has some very nice data virtualization capabilities. This means that we can use Lakehouse to access data that is physically sitting in some external system and/or data store. This technology is called Shortcut, and we can create shortcuts to, for example, AWS S3 bucket or Azure Data Lake, and bring data to Lakehouse and Fabric using this method. This will then mean that the physical data will stay in the external location, and is only shown through the Lakehouse and OneLake. So from the Fabric UI, you would be able to see those files even though those files are actually sitting somewhere else. There are many benefits of using shortcuts, and we will cover it in more detail in upcoming slides. But to name a few benefits, data doesn't need to be duplicated, and it stays always up to date. Also, the cool thing is that this technology is not only for files, and you can shortcut tables as well. Cool. Now we have data in our Lakehouse and we would like to access it. Well, there are several different interfaces that can be used to access data in Lakehouse. We can of course access the data using Spark, that we have been doing a lot in this series. Then we have the TSQL interface that provides similar interface than with Fabric Warehouse. But the limitation is that it allows only reading data, so this interface does not allow writing data back to the Lakehouse. And since OneLake and Lakehouse are based on Azure Data Lake, we can use ABFSS or Azure Blob File System API to access the data. Then we have some other endpoints like REST and analysis services that can be used to interact with Lakehouse and its data. Also, key thing to remember here is that these interfaces are powered by Microsoft Fabric capacity. So if you don't have a capacity running, you can't access the data either. Then lastly, we have the consume layer and different tools that can consume data in Lakehouse. Almost every tool in Fabric is able to at least read data from a Lakehouse. And you can use tools like data pipelines, data flows, notebooks, and event streams to interact with Lakehouses. And I would say that the most native tool for accessing this data store is Notebook, since it allows using Spark to access the data that we have already covered in this series previously. Also, you can access the data in a Lakehouse using Power BI and then have that data on your reports. And this access is not only limited to Fabric services, and we can use those different interfaces to access the data with many different external tools and services like with Azure Databricks or Data Factory or with some custom applications to name a few services. Next, let's talk more about the shortcuts, since they are one of the core concepts to understand in the exam. Many of the core features we already covered on the previous slide, but as a quick summary, shortcuts allow virtualizing data from external systems via Lakehouse, which eliminates the need for data duplication and makes sure that the data is up to date with the source since it is not physically copied. These shortcuts support ever-expanding number of sources, but at the time of making this episode, the supported sources are other Fabric data stores, ADLS or Azure Data Lake Storage, Amazon S3 or S3 compatible sources, Dataverse, Google Cloud Storage, and as a newest arrival, Apache Iceberg. And then these shortcuts can be used to bring in files or tables depending on the source. There is also one core topic with the shortcuts that is very essential in the DP-700 exam, and that is shortcut caching. This is a workspace level setting that can be turned on. In practice, this cache will store frequently accessed data locally in OneLake. For example, in our picture, if we would be reading the JSON file from the S3 bucket via shortcut, and we would have the shortcut cache enabled, if we would read it once, this file would be stored to the cache and following reads would then use that cache rather than the file that is actually sitting in the S3 bucket. This would improve the performance of our shortcut since we wouldn't have to do repeated reads to the external S3 location. This process is happening entirely under the hood, and if you are not aware of this caching, you won't be able to tell any difference than maybe that you can read data a bit faster in some cases. So this cache is completely invisible for users. Also, you don't need to worry about that you would be reading some old data when using the cache, since the cache knows if the source file is updated and it will then direct reads to that external location and then cache that new file. These cached files are then kept for 1 to 28 days depending on your configuration. Also, files larger than 1 GB are not cached at all, and currently this caching is only supported for Google Cloud Storage, S3, S3 compatible, and on-premises data gateway shortcuts. Next, let's cover the basics of delta tables, since they are good to understand in order to understand optimization and maintenance topics that we are going to cover next. In this example, we have a delta table called person, and it's in the DBO schema of our Lakehouse. Even though this table looks like a traditional database table when using and interacting with it, it is actually Parquet files in a folder under the hood that store data in a columnar format. Then we have a delta log that keeps track of those files. Then we can use delta tables in a very similar way we use traditional database tables. But what happens under the hood is a lot different. For example, if we insert some files to the delta table, the load logic will actually write new Parquet files to our delta tables folder and then also update the delta log about the new files. And then when we keep doing more and more inserts to our delta table, more and more files will appear. Other operations like updates, deletes, and merges work a bit differently. For example, if we want to delete data and run a delete statement to our delta table and delete one row there, the delta logic is not actually going to delete any data. And instead, it will mark the file where that specific row is an old or not in use anymore, and then create a new file without that row to replace that old file. Then also delta log is updated to know that there is a file that is no longer used in the latest version of the table. So in a sense, we start to build version history of the data. And you can think about delta table as this smart version control table. And due to this nature, delta tables have some cool features, like time travel that allows you to look at the past versions of the data. Also, delta tables support ACID transactions, which means that you can reliably use and read the data even though somebody would be writing it at the same time. Then schema evolution is supported that allows adding new columns to the table based on the incoming data. However, the issue what might happen over time is that the delta table will get very large and have many small files, and some of those files could be irrelevant since they are older versions of the current data. Luckily, there are ways to maintain and optimize delta tables that we are going to look at next. The first command or method that we can use to make sure that our delta tables stay in good shape is to use the vacuum command. This command will clean unused data files from our delta table folder. Basically, it will delete old files that are no longer used by the latest version of our delta table. This will have an effect to the time travel feature of the delta table, since this will physically delete data based on the configured time period. We can, for example, run vacuum for files that haven't been part of the latest version of the data in 7 days. Of course, after running this, we can use the time travel feature to travel only to that point in time and no longer backwards, since that data no longer exists. The primary goal of the vacuum is to free up space in our delta tables and in OneLake. Next, we have a command called optimize that will combine smaller files into bigger ones, so that when we're querying the table, there is less files to scan, which will then result to faster query speeds. Lastly, we have a V-order that stands for vertical order, and it is a write-time optimization and can be ran with optimize command. Also, it can be turned on so that it is ran always when writing data. V-order will group similar values together so that they are faster to query, and it will especially speed up queries with filters. The minor downside is that when turned on, it will slow down writes a bit, around 15%, but should make reads significantly faster, and thus V-order is a good option to have turned on. And it is actually enabled by default in Fabric, which in my opinion is a good thing. Then we have the OneLake File Explorer that integrates directly to your Windows Explorer, and you can use it to interact with files in OneLake storages like lakehouses. I wouldn't use this to directly interact with delta table folders other than maybe delete them, since delta tables are not meant to be interacted with this way. However, this tool is great for updating and adding new files to Lakehouse's file section where the raw files are. I can see that this tool can be beneficial to business users that want to update some reference data that is sitting in a Lakehouse. Next, we are going to hop into Fabric and check out Lakehouse in more detail there. Before we open Fabric, I would like to know that I spent a ton of my free time creating these videos for you, and that's why I would like to hit that like button and subscribe to the channel for more Microsoft Fabric and DP-700 content. This doesn't cost you anything, and I would highly appreciate that. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. But now, let's go to Fabric. Now we're in Fabric, and here I have my DP-700 workspace open. And here I have this lakehouse that we have created in the previous videos. Let's open this lakehouse and let's check it out. So, as we know, we have the tables here and we have the files here. And we have been actually writing data and using this lakehouse in the previous tutorials. So if you have been watching those, you should be already somewhat familiar with the lakehouse. But today we are going to dive a bit deeper in the specific features that we have in the lakehouse that makes it different from the other data stores that we have in Fabric. And like said, the big thing with Lakehouse is that we can store there any type of files we want. Basically, we can store there, for example, audio files, video files, CSV files, JSON files, Excel files, any files we want, because we can just treat those files as binary objects and not care about their contents. Also, let's go back to this workspace, and we can see that under this lakehouse we have these two additional items here. First, we have this default semantic model here that is created when you create a lakehouse, and this is basically a Power BI dataset that is sitting on top of our lakehouse so that we can start using Power BI with our lakehouse very conveniently without doing a much configuration here. Then we also have this SQL Analytics endpoint. And this is the TSQL interface that I was talking about in the theory section. Basically, this gives this warehouse type of interface on top of the lakehouse that we can then use TSQL to query the data in our lakehouse. But remember that this TSQL interface is read-only, and we cannot use this to write data. But this is one way of accessing the data sitting in the lakehouse using TSQL if your developers or end users are more familiar with TSQL and prefer working that way. But the limitation is that it's read-only. And now let's go back to that Lakehouse view, and like I said in the theory section, we can create table shortcuts. For example, if I would like to create a table shortcut to this DPO schema, I could click these 3 dots here and choose a new table shortcut. And this will then prompt this selection from which I can select the source I would like to use for my shortcut. But this time we are not going to create a new table shortcut here. And we are also able to create file shortcuts. So if I would click here one folder, we would be able to define a new shortcut here. And this time we are actually going to define one new file shortcut. So let's create a new subfolder here called DP-700 episode 12, and let's create that. And now I want to create a shortcut to this folder, and I want that shortcut to point to the Azure where I have this storage account, and to this storage account, and in this storage account I have a container to which I want to create that shortcut. And this container is called Data Lake. But before you start to do this shortcut, please check that you have the appropriate access to that storage account. And if you're going to use your personal account for the shortcut, you can go to the access control of the container, and then you can click this View My Access, and you need to check that you have, for example, this storage blob data contributor. That should be very much enough for creating that shortcut. And now let's close this, and then we want to check from the properties this connection URL. Actually, we need to edit this a bit and change this blob here to DFS. But yeah, let's take this URL here and we will edit it shortly. And this is going to point to that container to which we are going to create that shortcut. Now let's go back here, and then we are going to select a new shortcut, and then we are going to select Azure Data Lake Storage Gen 2. And then we are actually going to create a new connection. And then this will load up, and here we can see that we need to input this URL in the .dfs form rather than .blob. I'm not going to dive into specific details about that too much in this episode, but let's change that blob there to .dfs. And it is actually prompting me for this connection that I have already made, but I want to actually create a new connection so that you can see how does this happen. And then we would have some options to choose another authentication method. And some of these are way better than my organizational account, but I will now just go with this for the demo purposes. And then let's click next, and then this should create the shortcut to that container. And then we have to select to which folder we want to actually create that shortcut to. And I want to create that to the root folder called Data Lake. And let's click next here, and it will then create that shortcut there. And then we are able to see the data sitting in the Azure storage account. So now we have created that shortcut, and that shortcut is pointing to this specific container, and we can see these same files that we have via this shortcut here. So there's the temp folder, and in that temp folder we have that file in Azure Data Lake.txt. That is the same file that we can see here. And this way we can see how this data virtualization happens via shortcut and how to configure a shortcut. Next, let's quickly check out where we can find that shortcut cache that I was talking about, even though the shortcut cache is not actually applicable to the Azure Data Lake storage. But yeah, the shortcut cache is actually a workspace setting, and I will move my face from there, and we can open up the workspace settings here. And here we can see the OneLake, and here we can see enable cache for shortcuts. And I can turn this on, and then we would be able to define the retention period between 1 to 28 days, how long those files would be locally stored in OneLake if we would use the cache for them. And we can, for example, set here the 28 days, and now that setting is saved. And here is also an option to reset the cache if we want, so that those all files would be removed from the cache. But yeah, now we have configured that cache as well, and it can be found here from the workspace setting and OneLake settings, and here is the enable cache for shortcuts. Let's go back to the Lakehouse, and now let's talk about those vacuum and optimize commands that we covered in the theory section. And let's first cover how to run those commands from the UI. Let's use, for example, this table that we created here in the episode 11, this temperature stream table. and we can click these three dots here, and then we have this maintenance option here, and we can click that maintenance, and this will then open up this view from which we can then choose to run, for example, the optimize command and also run the V order at the same time. And then we are also able to run this vacuum command here. And then we are able to specify the retention period for those old files, meaning that this would then delete the files that haven't been used in the latest version of the data since that period. But yeah, I would, for example, run this for 7 days, and then I could click this run now, and it will start to run these optimize and vacuum commands for that table. And let's run that. But as you can probably tell, this would be quite a heavy process if you would have multiple lakehouses with, for example, thousands of tables. This would be then a huge task for somebody to go through all of those tables and click through those optimize and vacuum commands for every table. Luckily, we have the code way of running these commands as well, so we don't have to rely on the UI only. Next, let's create a new notebook, and let's use that notebook to run those commands. Let's clean this here, and then let's attach the lakehouse that we are using to this notebook, and let's choose that lakehouse. Now it has been attached, and then we can start to run those vacuum and optimize commands for the tables we have here. And here we can see one way how we could run those vacuum and optimize commands from a notebook. So basically we can use, for example, Spark SQL and specify those commands and run them to the table we want. So let's run these and let's see what happens. And finally, my session started after 4 minutes, and then this command took like 36 seconds to run. But yeah, basically this is how you could run those programmatically from a notebook. Then with vacuum command, we are also able to specify that amount of hours we would like to retain when we are running that command. For example, here I'm saying that I want to retain 200 hours in that table, so that we would be able to travel 200 hours backwards with the time travel feature if we so desire. So we would keep some old data sitting there just in case. And a best practice here is that you don't use really tight retain hours when you run this vacuum command. For example, if I would try to run this, for example, 2 hours, I think this would throw us an error message or something. Yeah, it throws this error message and tells that, are you sure you would like to vacuum files with such low retention period? Basically, the issue there would be that if somebody would be still using those files, for example, there would be a process going on that would be still using those files that are relatively new, then that process could fail or there could be some issues if you try to delete those files at the same time. But yes, there are some options that you can use to override that, but I don't see any point of like using this vacuum command with really tight retention periods. And of course, you can use these commands to build yourself some maintenance runs that would be run periodically and run for all the Delta tables that you have. Also, a cool little library that I want you to know about is the Semantic Link Labs that has many features, for example, optimizing lakehouse tables. But I don't think this is part of the DP-700 exam, so if you're looking to build some runs that would optimize and make sure that your Delta tables are okay, then check out this Semantic Link Labs library. But not more about this time. Next, I want to show you this OneLake File Explorer that you can install to your computer. And with this, you are able to access to OneLake data using this File Explorer here. And we can, for example, go to the workspace that I have been using here now. And then we can see all the data stores here that I have in that workspace. And then we can navigate to that lakehouse that we have been currently using. And then we can see, for example, these files and tables here. And then we can navigate to the file section and to the folder that we just created. And here we can actually navigate to the shortcuts as well. So when I'm navigating to this data lake folder here, now I'm actually navigating to a storage account in Azure. And here I have that file that I have sitting there. And now I would be able to modify this file that is sitting actually in the Azure storage account using my own computer here. But yeah, we can go back here and we can also check out those Delta tables here. For example, this episode 11 folder where we have that temperature stream Delta table. And here we can see that we have those multiple Parquet files here. And then we have this delta log here. So this is how the delta table looks under the hood, like we went through in that theory section where I talked about these Parquet files under this delta folder here. But yeah, this OneLake File Explorer is a pretty cool feature, and I would encourage you to explore this on your own and things that you can do with this. Next, let's have a couple of questions about the topics covered in this episode. Let's start with the first question. What happens when a cached file used in a Lakehouse shortcut has not been accessed within its retention period? Is it A, the file is permanently deleted from the source system? B, the cache is refreshed and the retention timer resets? C, the file remains offline but shows a warning about the retention? D, the file is removed from the cache and fetched again on the next access? Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D. The file is removed from the cache and fetched again on the next access, since this is how the cache will behave once the retention period is reached. A is incorrect since the file won't be deleted from the source. B is incorrect since there is no such functionality and the cache will refresh only if the data is accessed, but this opinion doesn't mention that. C is incorrect since no warning will be shown. Let's have another question. What does the vacuum operation in a delta table primarily target? A, all transaction logs that are no longer referenced. B, unused or outdated metadata definitions. C, physical Parquet files no longer referenced by the latest version. D, rows marked for deletion in delta tables. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, physical Parquet files no longer referenced by the latest version, since that is how the vacuum operation works and these other options here are incorrect. And that is all that I wanted to cover today. If you'd like to continue your learning journey towards getting that badge, check out the next video in this series. But now I thank you for watching and see you in that video.